sklearn, model selection, learning curve. Description. The learning curve plots the training and validation scores of a machine learning model as a function of the size of the training set. It is a useful tool for understanding the bias-variance trade-off of a model, and for identifying whether the model is underfitting, overfitting, or is just right. Inputs. Estimate the machine learning model to be evaluated. X the training data, which is a 2D array where each row represents a sample and each column represents a feature. Y the target values, which are the labels for each sample in the training data. Train sizes the sizes of the training sets to be used in the learning curve as a fraction of the total training set size. For example, if train size is 0.1, 0.3, 0.5, 0.7, 0.9, then the learning curve will be plotted for 5 different training set sizes 10, 30, 50, 70, and 90 of the total training set size. CV the cross-validation strategy to be used to evaluate the model. This can be an integer for k-fold cross-validation, a cross-validation object, or a list of cross-validation objects. Scoring the performance metric to be used to evaluate the model. This can be a string, e.g., accuracy, precision, recall, F1, a callable function, or a list of metrics. Shuffle whether or not to shuffle the training data before splitting it into train and validation sets. Random state the random seed to be used for shuffling the data. Outputs. Train sizes the sizes of the training sets used in the learning curve. Train scores the training scores for each training set size. Test scores the validation scores for each training set size. Steps. For each training set size in train sizes. Split the training data into train and validation sets using the provided cross-validation strategy. Train the model on the training set. Evaluate the model on both the training set and the validation set using the provided scoring metric. Record the training score and the validation score. Metrics. Training score the performance of the model on the training set. Validation score the performance of the model on the validation set. Visualization plots. Learning curve a plot showing the training score and validation score as a function of pay. Training set size. Fine-tune parameters. Train sizes the sizes of the training sets to be used in the learning curve. CV the cross-validation strategy to be used to evaluate the model. Scoring the performance metric to be used to evaluate the model. Uncertainty methods. Confidence intervals. The confidence intervals for the training and validation scores can be computed and plotted on the learning curve. This can help to assess the uncertainty in the estimated scores. Challenges and fixes. Challenge 1. The learning curve may not show a clear trend, or it may not converge to a stable score. Sample use case that resulted in challenge 1. The model may be underfitting or overfitting the data. Fixes to challenge 1. Increase the complexity of the model, e.g., add more features. Use a more powerful model to reduce underfitting. Decrease the complexity of the model, e.g., remove features. Use a simpler model to reduce overfitting. Increase the size of the training set to reduce both underfitting and overfitting. Challenge 2. The learning curve may be noisy, making it difficult to interpret the trend. Sample use case that resulted in challenge 2. The model may be sensitive to the specific splits of the data used in cross-validation. Fixes to challenge 2. Increase the number of folds used in cross-validation. Use a different cross-validation strategy, e.g., stratified k-fold cross-validation. Repeat the learning curve experiment multiple times with different random seeds and average the results. Challenge 3. The learning curve may be slow to converge. requiring a large number of training set sizes to be evaluated. Sample use case that resulted in challenge 3. The model may be complex, or the data may be large. Fixes to challenge 3. Use a smaller range of training set sizes. Use a different cross-validation strategy that is more efficient, e.g., leave one out cross-validation. Use a different scoring metric that is less computationally expensive, e.g., accuracy instead of F1 score. Challenge 4. The learning curve may not be informative for all types of models or datasets. Sample use case that resulted in challenge 4. The model may be a deep neural network, or the data may be very high dimensional. Fixes to challenge 4. Use a different visualization technique, e.g., a plot of the loss function or the model parameters as a function of the training set size. Use a different metric to evaluate the model, e.g., a metric that is more sensitive to the specific task or dataset.